All right, today's lecture is on redox reaction and the introduction to something called oxidation numbers. A redox reaction is a specialized type of reaction in which there is a transfer of electrons. Okay, so in the chemical reaction, one substance is going to lose electrons, and losing electrons is called oxidation. Another substance, which is, again, these are reactants because the reactants react to form products. So one of the reactants is losing electrons. Another reactant is gaining electrons, and the gaining electrons is called reduction. And you can see why they abbreviate that for redox. We get the RED of reduction and the OX for oxidation. We got redox. So this is anything that there is a transfer of electrons is a redox reaction. We have 5 types of reactions. If you remember back from honors or regular chemistry, we have 5 basic types. We have the synthesis reaction, we have the decomp reactions, we have the combustion reactions, we have the single replacement reactions, and the double replacement reactions. Those are the 5 classic types of reactions. Redox is a 6th type, and several of these types of reactions can also be redox reactions. For example, a synthesis reaction can be a redox. A decomp can be redox. A combustion can be redox. A single replacement can be redox. However, the only type of general chemical reactions of the 5, double replacement reactions, are never redox reactions. The other 4 can be and oftentimes are. Okay? So a way to remember this is Leo the lion says grr, or Leo says grr. Okay? Losing electrons oxidation, Leo. Gaining electrons reduction, grr. So that's a quick way of remembering, because oftentimes in a multiple choice question they might ask which substance is being oxidized, which substance is being reduced. The technique we use to balance redox reactions is called the half reactions method, which I'll get into talking about in the next lecture. Oxidizing agents and reducing agents are no longer part of the AP curriculum. I just wanted to put them on here for you to be aware of them. They used to be something that was required for students to know. They no longer are part of the exam. So instead, what they're going to be asking for is which substance in the chemical reaction is going to be reduced and which substance in the chemical reaction is going to be oxidized. They're no longer going to say what is the reducing agent or oxidizing agent. Okay? Now that substance, again, is always going to be a reactant. So which reactants are being reduced and oxidized? So whenever you ask that question, make sure you never select a product, because reactants, again, form the products. All right, let's look at how a redox reaction works and how we can assign oxidation numbers. All right, so we have the chemical reaction zinc plus hydrochloric acid. So zinc, solid, reacts with hydrochloric acid. Okay. What type of reaction is this? Well, if you went off of the 5 classic types, synthesis, decomp, combustion, single, double replacement, this is an example of a single replacement. The zinc forms positive ions, so it's going to kick out the positive part of HCl, which is the hydrogen. So we're going to get zinc chloride and hydrogen. Now, the form of the hydrogen is going to be its elemental form. And what does hydrogen exist as an element? Hydrogen gas. And hydrogen is always diatomic. Zinc chloride is an ionic compound. The charge on zinc is +2. The charge on chloride is -1. So we get ZnCl2. Okay. Now, the solubility rule, we would predict zinc chloride would form a solid because it doesn't contain a group 1 metal, it doesn't contain nitrates, it doesn't contain ammoniums. What they would tell you in the problem is that the ionic compound is soluble in water. So zinc chloride is soluble in water, so it's going to be labeled as aqueous. All right, to balance it, all we need to do is put a 2 in front of the HCl. Okay? All right, this is an example of a chemical reaction. Now, let's look at reviewing how to do a net ionic equation. All right, so anything that's labeled as an aqueous, we separate. Now, do I separate HCl? Is the question you're supposed to ask yourself is it soluble? No, HCl is an acid. And if you remember from the last lecture, if you have an acid or a base, the question you ask yourself is it strong? Is HCl a strong acid? Yes. Therefore, we do separate it. Okay, so the zinc metal I will not separate because it's a solid. We do not separate anything that's a solid, liquid, or gas. Okay, we'll separate HCl into its ions. We only break things apart into their ions. And there's a 2 out in front, so they're going to form 2 hydrogen ions and 2 chloride ions because there's the coefficient of 2. Zinc chloride is an ionic compound, and since it's soluble, if you have an ionic compound that's soluble, it immediately breaks apart into ions. So we're going to get 1 zinc ion, which has got a +2 charge, and 2 chloride ions, which have a -1 charge. And then hydrogen gas we leave together because it's a gas. Again, anything labeled with a G, L, or S, solid, liquid, or gas, will stay together. Do we have any spectator ions? Yes, the 2 chloride ions are spectators. And what we're left with is the balanced redox reaction. It's also the net ionic equation for this reaction. Okay, this is also an example of redox reaction because we're going to find out here in a second is that the oxidation numbers of these elements are changing, and whenever you have a change in oxidation number, it's a redox reaction. Okay? Again, remember, oxidation and reduction occur simultaneously. Something has to be oxidized as something is being reduced. You can't have one without the other. There is no net change in the number of electrons. So the amount of electrons transferred, if one releases 2 electrons, the other one has to absorb 2 electrons. Okay. Now, how do we determine if something is a redox reaction? We have to be able to do something called assigning an oxidation number. An oxidation number, in essence, tells us which way, in all the bonds of atoms, which way is the electrons in the bond more likely to be favorable. When we have a chemical bond, does one element possess the electrons more often than the other one? If so, the more electronegative atom is going to have a negative oxidation number, followed by the other element is going to have a positive one. Okay? So, in oxidation numbers, the oxidation number of an element in its elemental state is always 0. So if I go up above, zinc solid, zinc metal, its elementary state is the solid state. Okay? You'll notice in the periodic table in my classroom that the zinc is outlined in black. The black elements are solids at room temperature. So whenever zinc is in the solid state, that it's its elemental form, it has a 0 for an oxidation number. Okay? Put down a 0 for zinc. Hydrogen, over on the product side of the reaction, is also in its elemental form because the elemental form of hydrogen in its elemental form always exists as H2 gas. It's a diatomic element. Because it's bonded to itself, there is equal polarity, and therefore it has a 0. So whenever you have an element by itself in its elemental state, even if it's bonded to itself, it's going to have a 0 oxidation state. The oxidation number of an element in a monatomic ion state is equal to the charge on the ion. So really, an oxidation number oftentimes is confused with the ion charge. But the ion charge on an ion is equal to the oxidation state. Okay? So for hydrogen, this is +1. And for zinc, it's +2. Okay? Now, if we look at this, we'll notice that the zinc has gone from an oxidation state of 0 to now an oxidation state of +2. It has changed its oxidation state. And whenever you have a change in an oxidation state, that tells us that it is a redox reaction. Hydrogen is going from a +1 state to a 0 state. It too is changing its oxidation number and therefore is a redox reaction. Okay, now real quickly, if you look at the definition, is zinc being oxidized or is it being reduced? Losing electrons is oxidation. Well, if something loses electrons, does it become more positive or does it become more negative? If you lose electrons, what's happening? You're going to become more positive. If you're gaining electrons, you're going to become more negative. So the element that becomes more positive with its oxidation number is going to be oxidized. So zinc going from 0 to +2, we would say that zinc is being oxidized and the hydrogen is being reduced because +1, 0 is more negative than +1. So again, in any redox reaction, something's going to be oxidized, something's going to be reduced. Okay? Certain elements have the same oxidation number in almost all compounds. Group 1s are almost always +1. Group 2 is almost always +2. Oxygen is almost always -2. The 2 times that it isn't is when it's with fluorine. And the reason why is fluorine, which you need to add to this list, fluorine is always -1. Fluorine is never not -1. The only time fluorine is not -1 is when it's bonded to itself and it's fluorine gas. This is the elemental form of fluorine, and again, any elemental form has got a 0 oxidation state. But when fluorine is bonded to any other element on the periodic table, it has a -1 oxidation state. Why? It is the most electronegative atom. Okay? Oxygen is the second most electronegative atom, so oxygen is almost always -2 if it's bonded to fluorine. And the only chemical compound you have to be worried about is oxygen difluoride. Here, because oxygen is bonded to fluorine, fluorine has to be -1, and there's 2 of them. So that means the total oxidation numbers of the 2 fluorines add up to -2. What do you think the oxidation state of the oxygen has to be? +2. Okay? The sum of the oxidation states should always add up to 0, the total number of them, if it's a neutral compound, which OF2 is a neutral compound. So the oxidation state of oxygen with fluorine is going to be always +2. The other big exception is peroxides. You know it's a peroxide immediately whenever you have something to O2. This is an example of hydrogen peroxide. In here, oxygen cannot be -2 because hydrogen, if you remember, only has 1 electron. Hydrogen can only be either +1 or -1. Because oxygen is the second most electronegative atom, I know hydrogen cannot be negative, it can only be positive. So the hydrogen is +1. Well, there's 2 of them. There's also 2 oxygens. So in order to balance, both of the oxidation states have to be the same because there's 2 of each. So if hydrogen is +1, the oxygen has to be -1. So oxygen is 95% of the time it's -2 in a compound. The only time that it's not is in oxygen difluoride, where it's +2, and when it's a peroxide, when it's with a group 1 element in which it's the ratio of 2 to 2. That's when it's -1. Okay? Hydrogen is almost always +1. The only time that it isn't is when it's with a group 1 metal, like KH. And that's because hydrogen actually has a larger electronegativity because the group 1 elements have the smallest electronegativities of all the elements on the periodic table. And therefore, group 1s are +1, so the hydrogen can't be +1 because that does not add up to 0. It has to be -1. So hydrogen is almost always +1, except when it's with a group 1 metal and it's -1. Okay? So the sum of the oxidation numbers should add up to 0 if it's a neutral compound. If it's a polyatomic ion, it has to add up to the charge on the ion. For example, if you have nitrate, the sum of the oxidation numbers are not going to add up to 0. They have to add up to -1. Okay? All right, so oxygen is with nitrogen. It is not a 2,2, it's not a peroxide, and it's not with fluorine. So this means the oxygen has to have an oxidation state of -2. But remember, there's 3 of them, so we got to write -2 3 times. Okay? We are missing a number. That's the oxidation number on the nitrogen. The summation of all the oxidation numbers have to add up to -1 for this substance because it's a polyatomic ion. Okay? Therefore, what number does x have to be that will cause this equation to add up to -1? Well, if I add them up, I'm going to get the algebraic equation x minus 6 equals -1. Add 6 over, and we get positive 5. So the nitrogen has a oxidation state of +5. The oxygens each are -2, and that then adds up to an overall charge of -1. So on the national exam, the nitrogen would have an oxidation number of +5, and the oxygen would have a negative oxidation number of -2. Not -6. We don't add them all together. Each oxygen has an oxidation state of -2. The summation of all of them have then got to add up to the charge on the ion. Okay? All right, so go ahead, let's practice these 6 examples. Why don't you pause the lecture now and see what you get for these, and then we'll come back and we'll see how well you're doing. Okay? All right, the first one, you'll notice that they want to know the oxidation number of oxygen in O2. Well, who is oxygen bonded to? Itself. If you have an element bonded to itself, the only oxidation number it can have is 0. Okay? All right, what is the oxidation number of the chlorine and sodium chloride? Well, sodium is +1. Chloride is -1. Since these are monatomic ions, ions by themselves, not with oxygen, the charge on the ion is also the oxidation number. Okay? Carbon and carbon dioxide. Again, carbon is not bonded in a 2:2 ratio. It's not a peroxide, and it's not bonded to fluorine. So each oxygen must be -2. So there's 2 -2s. What does the carbon have to be that it's going to add up to 0? +4. So the oxidation number of the carbon is +4. So that +4, -2, and -2 summate to 0. All right. What happens when you start getting to 3 or more elements? You have to look at the first series of rules and then apply them. So the first one, typically we'll be asked to figure out an element that's in the D or P block that is very hard to determine. We figure it out by knowing the other ones. What must the oxidation number be on each of the sodiums? Sodium is a group 1 element, therefore it must be +1. Okay? There's 2 of them, so that's going to total a +2. The oxygen is not in a 2:2 ratio. It's not a peroxide. It's not with fluorine. So that means each oxygen is -2. So when I add those up, I get -8 and +2. -8 and +2 add up to -6. So what does the sulfur have to be? It has to be +6 to balance out so that all of the oxidation numbers now will add up to 0. Okay? Potassium permanganate. Again, potassium is group 1, so it's +1. There are 4 oxygens, which are all -2. So that adds up to -8. So we have -8 plus 1 is -7. So the manganese has to be +7 so that we have +8s and -8 to cancel. Okay? Oh, excuse me, I screwed up there. It was asking just for the potassium, my fault. So the potassium would be just +1. The manganese would be +7. All right? So that's how we assign oxidation numbers. And if we're given a chemical reaction and asked to assign oxidation number, we can then use them to predict if the reaction is redox or not. Okay? All right, lastly, here's a couple other examples in a chemical reaction to see if a reaction is redox or not. What I'd like you to do real quickly now is pause this lecture and assign an oxidation number on top of each of the elements in the reaction, and then tell me if this is a redox reaction. All right? Please do that now. Okay, so the first reaction, HCl, hydrogen is almost always +1. And remember, in chemical formulas, the first element is the less electronegative one, so it's always going to have a positive oxidation number. Sodium is +1. Okay? Hydrogen is also +1 because it's bonded to an oxygen. Oxygen is the most electronegative atom, which means it is -2. The only time hydrogen is not +1 is when it's with a group 1 metal, okay, when it's bonded to a group 1 metal by itself, not with oxygen. Okay, the hydrogen is bonded to the oxygens here because we're looking at the hydroxide ion, which adds up to -1. Okay? All right, so because oxygen is bonded to hydrogen, the hydrogen we know is +1, the oxygen is -2, and that summates to -1. And this is why hydroxide has a -1 charge on it. Okay? Water, each hydrogen is +1. And the oxygen then must be -2, so they add up to 0. All these chemical compounds, there's not a charge in any of them, so they always have to add up to 0. And sodium is +1, chloride is -1. Do any of the elements undergo a change in oxidation number? You'll notice that the hydrogens are both +1 on the left side, and it's +1 on the right side. There's no change in oxidation state. Chloride is -1, -1. No change in oxidation state. The sodiums, the oxygens, there is no change in oxidation states. So all the elements, there is no transfer of electrons. So this is not a redox reaction. So if the reaction does not have a change in oxidation numbers of any of the elements, it's not redox. Okay? And also remember, this was a double replacement reaction. Two compounds forming two new compounds. Whenever it's a double replacement reactions are not redox reactions. All right, let's look at the next one. Aluminum. Aluminum is in a solid state. It's by itself. It's not in its ion state. Okay? As an element by itself, it's going to have a 0 oxidation number. We just did HCl up above, +1 and -1. On the right side, H2, hydrogen gas, that's its elemental form of hydrogen. It's bonded to itself. If it's bonded to itself only, it's going to have a 0 oxidation number. Immediately, I can tell that this is going to be a redox reaction. Why is it redox? Because the hydrogen is going to go from a +1 oxidation state to a 0 oxidation state. And therefore, is hydrogen being reduced or is it being oxidized? It's being reduced because it's becoming more negative. Chlorine in aluminum chloride is -1. There's 3 of them. So what does the aluminum have to be? So that it sums to a 0 because there's no charge on the chemical compound aluminum chloride. It's a neutral ionic compound. It has to be +3. So who's being oxidized? You'll see chlorine, -1, -1. It's not changing at all. The aluminum has gone from 0 to +3. And therefore it has become more positive, and that makes it be oxidized. So in a multiple choice question, I could ask which substance is being reduced, which substance is being oxidized. Okay? So if they say substance, which substance is being reduced, the substance would be HCl. However, if they said which element specifically, which element in the reaction is being reduced, then you would say hydrogen. Okay? So if it says substance, you're looking at which reactant, right? Which would be HCl. All right, so that's an introduction to oxidation number. There's lots of different videos online if you need more practice from other individuals that talk about it, but hopefully this gives you a good basis for oxidation numbers. This information is actually in chapter 20. I should have probably mentioned at the start of the video. That's where you'll find this information. But now I do have a homework set where, again, I give you some more practice problems to try assigning oxidation numbers because it's very important in order to balance redox reactions. Okay? If you have any questions, again, don't be afraid to contact me. Thank you.